Hello everyone, this is a structural analysis application tool for the moment distribution method for beams. It's a teaching and learning tool. Basically, it enables the student to create their own problem and get the solution in both tabulated and the graphic forms. So you will be able actually with this application to compare your own solution with the program in terms of correctness, etc. And you will be able also to compare your hand calculations with the table produced by the program in case there is a mistake you can learn from. I'll show you here an example. So this is an example. You create this example yourself, so you choose whatever configurations, whatever load applied here on the various spans. So what will happen is the program will create this table for you. We have here up to 12 iterations to get the final moment, and also the program will show you the shear force diagram here, and you will see also the bending moment diagram. In addition to this, you should be able to see for each span how the reaction is calculated and the final values. So here, for example, for span AB, so there is left and this right, so that's a span, so this is a left support and this is a right support, and so on for the rest of the spans. So the action from the span load, so these are the span loads, so you can see that the reaction for the left side of span AB is this value, and so on for the right side of the span, and so on for the rest of the spans. Also, the reaction from the end moment that you get from the moment distribution method, and finally the full reaction at each support. So for support A, we have this value, B, and so on and so forth, and the final check to make sure that the summation of all the loads applied to the beam equals the reaction. So let us go to the application and see how we can solve this problem, and hopefully you will like this application. So it's an Excel application. So we'll double click on this. So it loads the application here. It takes a bit of a few seconds to do that. So when it uploads the application, this is what you will see. It's telling you here to choose a new problem, and the first option, we have four options here. First option is when you don't have to do any modification to the nature of the end support, changing the stiffness if the end support is pinned or roller. And here, if the end pin or roller, and you would like to do the stiffness modifications for the spans, and this is a symmetrical beam, and this is asymmetrical beam. So in our case, for the problem that I showed in this example, I will press this one here. I assume I don't want to do any stiffness modification, so you press this one, and actually it opens this form for you. We have the put the problem here on the other screen to put the load. So let me zoom this here so that we can see what we're doing. So the first here, let me explain quickly the contents of this, and I'll bring this back. This is the various loads that you can apply: a distributed load, triangular load, both sides, and then three cases of concentrated loads, and also you can add a concentrated moment. So for this particular problem that we have, so we have support A here. So type support to choose. This is a left roller, and for the beam, for beam B, so it's a middle support, so it's middle roller here, and for C, still middle roller. Now, actually, I have more than one support, so I can say add new support. So it's it's adding a new support. You can do this before you start actually, because we have here up to support E, so I can see D and E. So I have actually, for this particular case, I have 1, 2, 3, 4 spans. That's one span, two spans, 3 and 4. And then for G, so it's also middle roller or pin, and for E, based on our problem here, so it's a fixed support. So for E, I'll put here right support fixed. So this way I have actually already assigned or specified the support conditions and the type. So here is the span data. So basically here it's 2 EI, 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 and EI. So I would put here the relative stiffness as 2 for first span and 1 for the rest. So that's 2, 1, 1, and 1. And as for the span length, I can do this here. I have 8, 6, 6, and the rest also are 6. So 8, 6, 6, 6. Now we go to the span loads. For each span, we will put whatever belong in terms of the load. So I have here for span AB, I have concentrated load. So I will go to load 5, and the A1 is basically the distance from the left support. In this case, it's 4 meter and the load is 50 kilonewton. So I'll put 4, and this is positive in the direction shown here in this icon. So now I am done with span 1. For span 2, I have only distributed load, it's 40 kilonewton meter. So I will actually go here and put this one here, because it covers the full span, so it's 6. And we said that the load is 40, so I'll put here 40. So I'm done with the second span. For the third span, I have triangular load. So here actually, yes, okay, for the third one, we put the distributed load for the triangular, which is load 4 here. So I have W equals 60, so I will put here at 60. And then the last span, I have concentrated load in the middle, that's 3 meter 50 kilonewton. So this would be here, that's 3, and this would be 50. So we make sure that we have put all the loads correctly. So the first one is concentrated 4 and 50, which is span AB. For the second one, we have distributed load, that's 40, and it covers the full span, that's 6. And then for the third span, I have here the 60, put the 60. And for the final one, I have concentrated load at 3 meter from the left. It's always this A1 distance measured from the left. So I have 3 meter, and I have this is 50. So I can now continue with this here. So basically, I filled all the information for the problem at hand. First, here it says save support data. So I'll save the support data. That's number 1. And then I say to save span data. I save span data. 3, save span loads. So here I'm seeing actually a message. The message says, so I'm seeing here a message saying review drawings loads on this sheet. That's referring to this sheet before solving. When done, press solve and the exit button to review the results. So I press OK here, and I can actually go to this spreadsheet here. Can move this aside for now, and I will check that the loads are correct. So I see here distributed load, and I see triangular load, and I see concentrated load here, and the spans also, that's 8 meters, and then the 6 meter, 6 meter. It looks fine to me. So with this, I can actually bring back the form and say solve and exit. So I solve here, and then this gives me the solution. As simple as that. So what do we have here? So basically, this is the results in graphical form. You can see this is a shear force diagram, and they have the values here. You can actually get the value at each point when you check on the drawing itself. And this is the bending moment, and I have here for each span the thing that I showed you before in the example. So I have the reaction at each support, and I have also this check that says okay, reactions balance applied loads. Here I have the tabulated results. So that's the tabulated results here, which is exactly the same thing that I showed you before when we discussed this example. So 2 minus 22.79 minus 22.79. So it's as simple as that. And the beauty of this is, like I said, you create your own problem, and the software will solve it for you, and you should be able to do the hand calculations and check against what the program produces. Hopefully you like this application. Thank you very much for paying attention.